Hey friends, I'm Scott Hanselman. This is Azure Friday. I'm here with Manny and we're going to talk about Azure Service Fabric for Linux.
That is right.
You're a major Linux person. You don't even know how to use Windows.
I wouldn't say that. I know to use Windows
I
and Linux.
I saw your Tmux and I was like, I wish I learned Tmux when I was a boy.
Well, what do you say?
Well, it's a new Microsoft, and this new Microsoft appreciates Linux. We do all kinds of amazing stuff, and you're here to show me some amazing stuff with Service Fabric.
Indeed. So we actually just made Service Fabric on Linux generally available as a container orchestrator.
That's pretty exciting.
That's pretty exciting. And I have a few demos lined up that actually shows you that, hey, these are the same bits that we are actually using even on Windows to run things like SQL with a couple of million databases, EventHubs with maybe a few trillion events, and so on.
Without getting too much into the details, is Service Fabric written in like cross-platform C?
Yeah, so what we actually, so most of the code, the underlying platform code is written in C. And some of the storage stack was actually written in managed code, so we are actually converting it to native code so we can actually not only support multiple operating systems, but also multiple languages will get the benefit of our stateful stores.
Very exciting. So if someone is listening to this and is already doing Service Fabric on Windows, what would be a reason for them to use Linux?
Well, a couple of reasons. One, a lot of folks actually do use, as they say, we want to let you use task-appropriate languages, frameworks, and OSs.
Makes sense.
So you might actually have some Linux code that is lying around, Linux executables. So you will actually want to keep those containers or those executables, you want to run them. And you want to get the power of the Service Fabric system in terms of orchestration, in terms of its store. You want to get all that.
Right.
So that's case number one why you would want to use Linux for certain cases.
Okay, cool. You have a demo for me.
Yeah, and the other thing I just want to call out, why would you want to use Linux? This comes down to some people are more familiar with Linux development tools, Tmux, for example, shells, for example, Eclipse and Eclipse plugins, Jenkins, those kinds of tools.
So use what makes you happy.
Use what makes you happy, yes. So
that's great.
And the runtime is pretty much the same. And actually, if you go into the browser, the way I create a cluster, you can do this via ARM templates as well.
Okay.
It's pretty much the same. I'm not going to really, I'm just going to say, hey, create a Service Fabric cluster. The same familiar portal UI comes up, and in addition to all of these things, we'll have, hey, Ubuntu server. And I should mention here that, right now we are starting off with Ubuntu, but we do have plans for RHEL, for example, in the coming months. So I'm not going to go ahead and create the cluster, but you can fill in this and you can create the cluster. Most of the interactions or interface that you do with a cluster are pretty much the same across Windows and Linux.
Okay.
It's your development environment that's completely different. You use Java and Eclipse, you use your CLI instead of PowerShell on Windows, so that changes. So with that, let me actually show you maybe a small cluster that we have up.
Okay, so this is one that you've already created to save some time.
Yeah, to save some time. And this is a small cluster that we have up. As you can see, it has
small, just 2007 nodes.
Just 2007 nodes.
Petite.
Yes, it's
cluster.
a petite cluster. And look at the number of containers that are up. Maybe it's not clear from the replica count. It's a Service Fabric concept for the number of services that are running.
Wow.
And this is the number of containers that are actually running live on that cluster. And this is an actual Azure cluster with 1 million containers.
I respect that you brought me 1 million containers for Azure Friday.
It only takes us like, once the cluster is set up,
Yeah.
it takes about maybe 2 to 3 minutes right now. And we still have some improvements that actually even brings that time lower. So we can actually get up to 1 million containers in a couple of minutes.
That's fantastic. Now I have to think about what I'm going to do with all those containers.
And to make this even more interesting, I'm going to do a failover of an actual node in this 2000 node cluster and see how well the system reacts.
Oh, wow.
And you're going to see something that's very counterintuitive.
Okay.
And I'll tell you why.
All right.
And the reason it's going to be counterintuitive is because you're going to see let me explain this. So when I take down a node, you expect the count to actually go down, and then Service Fabric sees, a node is down, so let me move it, and brings it back. But in this particular demo app, the way that I've actually set up is I'm actually caching reports for a few seconds.
Okay.
So the containers are actually reporting to a service on the node saying, hey, I'm up every few seconds. The service on the node is reporting to an aggregator service, which is collating across all these nodes and saying, hey, I have 1 million containers right now. And since I'm caching these reports for a few seconds, what you're actually going to see is when I kill a node, this number actually goes up because failover is happening that fast and then comes down.
Wow. Which I suppose would be an ideal scenario.
Which would be an ideal scenario. But in reality, you only have the million containers up, but the failover happens so fast that you actually see the blip that is counterintuitive. So let's go ahead and try this out. So, I'm showing you the nodes, and you can pick your node. Which node do you want? So you're
just going to kick one?
I'm just going to kick one. So I'm going to take this guy, and I'm going to do a deactivate restart on it. It's going to tell me it's a bad idea. You don't want to do this. But hey, well, what the hell? Let's just do that. Oops, 16. And deactivate restart. And in a few seconds, what you're going to see here is that, hey, the count starts actually going up before it actually stabilizes back to a million containers, assuming that I did actually press the right button.
So this refreshes every 10 seconds?
This refreshes every 10 seconds. So let's actually see this. And this is assuming that I actually did do it. So.
Well, when you kick it over, you have to type in the name in order to...
so you actually see, because all the nodes are now reporting every few seconds to the aggregator service.
Right.
But since the aggregator service is caching reports from all the other nodes that haven't refreshed, it's actually counting those as well. So it's effectively a bug in my code, or it's not so much a bug. I just put the time so much so I can actually show you this. And now you see that it's back to million containers. So
but the essence of this is no downtime.
No downtime.
That's the essence.
That's the essence.
That's pretty amazing.
Even at a million containers, failover happens in the blink of an eye.
That's
and
fantastic.
This is a 2,000 node cluster.
Right. So you get the same great experience on Windows or on Linux, and then when you're on Linux, you can run, as you said, Linux-appropriate workloads, whatever makes you happy.
And if you're used to a Linux development environment, you can use that. Doesn't matter.
What is the development environment like? I know that when I was doing this in Windows, I had to understand certain XML files and manifests and packaging and things like that. It was mostly a Visual Studio type experience.
Yeah. So in this particular case, what we did is, for example, if you're writing our programming models are in preview, we used Eclipse, for example. You can always use Yeoman, which is what ASP.NET uses to create templates, to create .NET Core applications or Java applications. So, and of course, you can use a CLI to manage a cluster. I have another demo to show you.
Please.
So this is kind of like the catchy one. Hey, million containers in 2,000 nodes.
No, you've impressed me. You have my attention.
So I have another cluster setup just to show you some orchestration capabilities. This has two types of nodes, blue VMs and red VMs, just 10 nodes. It's again a cluster in Azure. And what we normally do is, in order to become a little more secure, we actually set up two node types and say only one node type is actually has a connection to the external world. So in this case, only blue VM can be hit from the external world, red VM cannot. So two node types, blue VM, red VM is not accessible.
All right.
So I'm going to go ahead and now run a script. This is just Service Fabric, since you asked me. Service Fabric CLI, SFCTL. So it gives you, a command line experience to interact with the cluster, equivalent to what PowerShell would give you on Windows. So let me just go ahead and run this. So I have an app that I'm deploying. And I'm just actually spitting out like what is coming out. So it's basically selecting a cluster, it's doing the application upload, it's doing the provisioning, and in a few seconds you'll actually see this, hey, the app shows up here in real time.
I saw, by the way, you had a Node front end and a Python back end.
Yes, I have a Node front end just to show that it's polyglot, so you can run what you want. And let's do a refresh here. And it's not going to work. The reason it will not work is because I purposefully put both my front end and my back end in red VM nodes, just to show you placement constraints. So it's not going to work because both of them are sitting in the red VM node type, which cannot be accessed from the front.
Right, they're private. Externally.
So let's actually fix this. Now what you can see is I'm putting the front end, the Node.js front end, in a blue VM node.
The blue VM just
so now it should work. And in a few seconds, let's just make this a little bigger. Once it's basically downloading the Docker image.
I see the Node front end on the red, and then it calls the blue, which is not accessible.
Yeah. So now you can see the Node.js front end is running on blue, so you can actually see this, and you can see my graphic skills. And all this is happening in real time. Now let's do a scale up.
That was a pretty fast deployment too.
Scaling up, so you will actually, let's go back here. It's actually creating now 5 instances of each. And you see the warning because it's actually telling you, hey, you wanted 5 instances. We have 1 instance right now, so we're building it. So it's just giving you a warning message, which will go away in like a few seconds. Now we have 5 instances of each. And if I were to keep refreshing this, you will actually see that I'm hitting different front ends. Blue VM 4, Blue VM 3, so on. Now let's scale this back down because I don't need to run so much. And it will go down to, I think, 3 and 2 is what I had configured. And there it is. Again, in lifetime, real time, 3 and 2, scale up, scale down, placement constraints. And now actually let's do a zero downtime rolling upgrade. If you weren't impressed with my graphics skills earlier, you will be now. So I'm starting a rolling upgrade. So I look at my cluster. In a few seconds, it's going to tell me, hey, there's an upgrade in progress as soon as the application v2 is registered with the runtime. So it's actually registering it right now. So in a second, you will see a pop-up coming here saying there's an upgrade in progress. And the upgrade has started. It's moving from version 1.0 to 2.0. And since my application has 3 instances, it's just updating the front end. Has 3 instances of the, has a front end and a couple of instances of the back end. What you're going to see is as soon as it creates the version 2 of my front end, if I refresh fast enough, I can actually see, depending on which endpoint I
when
get.
it's version 1 and it's version 2.
Yeah, so you can see that as soon as it actually completes one upgrade domain. So it's still building. OK, now it's almost done. So now if I actually go here, and I need to be a little lucky here, but let's do this. Ta-da, version 2. And if I keep refreshing it.
Version 1.
And you never lost any availability even when the upgrade was in progress.
We haven't seen a single server error or even hiccup.
Yeah.
Fantastic. All right, well, let me ask you a couple hard questions then.
Sure.
Azure itself offers a number of different orchestrators, open source orchestrators.
Yep.
Why would one, or how would one know which orchestrator to pick?
Yeah, so Azure wants to, we want to offer choice. So, we want to provide you with the best experience irrespective of which orchestrator you pick. So if you are kind of enmeshed in the open source stack and you want to use you want to mix and match various things, you want to say put console for your service discovery, or you want to play with something like that, we support it and we'll give you the best experience there. We do have the open source stacks, we'll provide you. But on the other hand, if you want to know, hey, what is Microsoft running internally? What are you running SQL on? And can I have an integrated end-to-end experience where you can pick up the phone and call me? Don't call me, but if you want to do that, then we provide you with Service Fabric, which is the orchestrator that is built by Microsoft, which is running, hosting all our first-party services.
Very cool. Now, is this in preview right now, or can I make this happen in production today?
Service Fabric on Linux as a container orchestrator is now in production. You can use it in production.
Seriously?
Yes.
Fantastic. So I can go check this out right now?
Yes, you can.
All right. Well, I'm going to leave here and immediately go check out Azure Service Fabric for Linux. I'm learning all kinds of great stuff from Manny here on Azure Friday.